Thank you very much, Ryan, and welcome to everybody that's joining us here today. Today we're going to be talking about Chapter 7, which is a section in the IRIG 106 standard that discusses how to transport data. And we will discuss what you need to know to successfully record that data. So first of all, what is Chapter 7? Chapter 7 starts with data coming from an aircraft typically. This could be sensor data like bridge sensors, accelerometers, strain gauges, that type of stuff, avionics. It could be bus data like 1553. It could be video, really any data that might be coming off of the aircraft. And that data would be fed into an airborne recorder system, and that system would then turn that data into Chapter 10 packets for each of the different types of streams. Then the data would be encoded into PCM, and this is this chapter of the standard that describes this is Chapter 7, which is why we call it Chapter 7. It's not very creative, but it is what it is. This comes down as ones and zeros to the ground as PCM. And then at that point, will be picked up by a receiver, and then the decom system, we're going to be using Omega Next decom to describe this, but any decom system that can handle Chapter 7 will do this. We'll pull out the Chapter 10 packets out of the PCM data, and then you can parameterize the data and display it and do analysis on it, etc. To successfully record just the Chapter 7 stream, you don't really need to know anything about what's going on in the stream. The stream itself is just a PCM stream. So you do need to know the frame geometry of the Chapter 7 stream in order to record that. But you really don't need to know any of its contents, and you'll still get all the data. You won't be able to decom and get parameters out of it. You will get the data. However, if you want to break out the Chapter 10 packets from them, then you do need to know some specific things to get locks on the data. You need to know what type of data it is, and you need to know the Chapter 10 ID number. Now, that's embedded in the data as it comes down. So the software can fetch some of that information from you. For most data types, that's all you need to lock onto the data and get a good recording. For some types like PCM, for example, if you have a PCM embedded stream in the Chapter 7, you still need to know the frame geometry of that in order to decom the data. So the important takeaways of that is you need to know the Chapter 10 number and the channel types for each stream. So I'm going to pull up Omega Next software here. This is Parraid's decom software, and we're going to start as if we're getting data. First of all, you need a source of data. In this case, we're using a data file, but the source can be any of our equipment. It could be Ethernet data. It could be all types of data. So, but I'm not going to get into too much of what sources will do at this time. So I'm going to just pick a data file. I've already got one ready to go here. And in this data file, we've got two things. We've got time, because it's a requirement for a Chapter 10 file. And we have PCM, which is the Chapter 7 stream. So, but the Chapter 7 stream really is just PCM. So the next thing we want to do is we're going to set up our stream. So I'm going to go ahead and get our time stream. I'm just going to call this one time and put a little color around it so I can identify it quickly. And then I'm going to map that to the time channel that's in the data. And note the Chapter 10 channel number for that is 10. This is the time that's the time for the Chapter 10 stream. So if you remember back to the display I just showed you, have a recorder on board the aircraft. So there's a time associated with that and the data that comes in on the aircraft. And then that PCM stream comes down to the ground, and there's another time associated with the ground station and when the ground station receives that data. And this is the time for the ground station that I'm describing here. Next, we're going to add a stream. And in this case, I'm going to add a Chapter 7 stream. The Chapter 7 stream is, it is a PCM stream, but it's got some fixed parameters, and we'll talk about that in the middle in a minute. But I'm just going to call this CH7, CH7 stream, so that we don't get this confused. Excuse my typing. There we go. And I'm going to make that yellow, and then I'm going to map that to the Chapter 7 stream in the source. So now we just have to set up the frame geometry for the Chapter 7 stream. So in this case, it's 10 megabits per second for its bit rate. It is in throughput mode. And I'm assuming when I talk about this stuff that people understand what I'm talking about. If you don't, feel free to ask questions and we can answer those questions later. Since it's a data file, I can skip the receiver, combiner, and bit sync stuff because we don't have any of that. And note that the common word length here is fixed at 8. I can't change that. And that's because the standard fixes it at 8. In addition, the number of minor frames is fixed to 1, so I can't change that either. However, the words per minor frame are adjustable, and in this case, it's 893. And the frame sync length and pattern are also fixed. So at this point, I'm done with everything I need to do to record the Chapter 7 stream. If I start recording, and I set this up right, you'll see that I'm going to get locks on the time stream and the Chapter 7 stream. And I do indeed. So that at this point, I can record this, and all the data, including the embedded data that's part of that Chapter 7 stream, is included, even though I'm not breaking it out in decom. But let's assume that we want to take a look at some of that data ahead of time. Now, when I started this in Omega Next, the log turns yellow, which lets me know that there's Chapter 10 packets embedded in this data that I have not yet mapped. And indeed, it shows me the Chapter 10 ID numbers as well as the type of data it is. So we're going to go ahead and include those types so that we can take a look at that data in real time. So down here at the bottom, let me close this, we're going to add the channel. So I'm going to add a time channel, which this would be the time that is on the recorder, that's associated with the data on the recorder in the air, the airborne recorder. And then we had a couple of 1553 channels, so add 1553 channel. And then we need a second one. And then we had 2 video streams, just remembering this, an analog stream, and there was a PCM stream. So I have the PCM stream here. Now note that at the bottom here, there's actually 2 sets of Chapter 10 numbers, and there's a reason for that. The set on the left corresponds to the Chapter 10 numbers that are embedded in the streams that are part of the Chapter 7 stream. And on the right, these are Chapter 10 numbers that Omega Next is going to use to connect to those streams. They can be the same as the embedded streams, but they don't have to. There are times where you wouldn't do that. For example, if your time stream here was the same as the time, had the same Chapter 10 number as the time stream from your ground station, say that was 10, and this was set to 10, you would get a conflict. So you'll see an exclamation point. So you wouldn't want that conflict. In this case, we don't actually have a conflict, but I do need to set these to the correct numbers, so I can look if no one gives it to you ahead of time, which usually that would be the case. I can just look here in my log to see that my 1550 streams are 5 and 4 respectively. So I'll put that in 4 and 5. Note that I'm getting some conflicts because those numbers don't match, but they'll clear up when I change this. 6 and 7 for video. We'll change this to 6, and this one to 7. And then analog was 2, and time was 1. So analog was 2. Time was 1, and then my PCM is 3. So I've changed this to 3, and that should make all the conflicts go away. And they do. Now, again, as I said before, these, you can set these up to match what's on this side. And very often I do that just to avoid confusion. But as long as these are unique, it doesn't matter. So I'm going to leave them as they are because you'll see it's pretty easy to connect to it anyway. So now what I want to do is add these stream types so that I can get parameters out of them and look at the video and all that kind of stuff. So I'm going to go ahead and add a time stream. Even though we have a time stream, remember this time stream is associated with the airborne recorder. So to avoid confusion, I'm going to call this Chapter 7 time. And then I'm going to give it a little color as well. And then I'm going to click on the source channel, and I've got 2 choices here. These are the 2 times that are available, but I want the time that's in the Chapter 7 source. So that's a separate time. That's my Chapter 7 time. Then I'll go ahead and I'll add a PCM stream because there's a PCM stream in here. And to avoid confusion, again, I'm going to call it Chapter 7 PCM. And I'll give that a different color. You don't have to put these colors in, by the way. It just makes it easier to identify the channels, especially if you're looking at it from a distance across a control room or something like that. And again, I'm going to use the PCM channel that's embedded in the Chapter 7 data. Now, in order to decom the PCM channel here, I do have to put in all the frame geometry. So I'm going to go ahead and do that now. So in this case, it's a megabit per second. And the throughput, it's actually, this is pack data. I'm going to put that as pack data. I'm not using the bit sync or anything here, so I can skip down. The number of minor frames, the major is 32, and I have 511 words per minor frame. This is calculating my number of bits per minor frame, but in this case, I actually have a 32-bit frame sync, and the frame sync is FE6, E2840. I'm going to put my mask as all Fs. And that sets up my minor frame, but I do have subframes, so I'm going to turn my counter on. And you can see as I'm doing this, it's building a word map here on the right in real time. So it's showing me my PCM frame here. So now I'm setting up my major frame or my subframes, and I want to set up my counter. So I've got 32 minor frames. So I'm going to need 6 bits to count to that. And this is showing me a graphic of where the counter is in my word, in my SFID word. But I want those actually the least significant bits. So I'm going to move the most significant bit. And oops, start that location. Let me try that again. So this graphic is handy because I was working with different things at a different number in my head. It's showing me that I have this in the right place. In that's why. Excuse me. I realized why I have a different number in my head. These are actually a 16-bit common words, not 12-bit, which was the default. So this is supposed to be 11. There we go. Okay, so that's showing me that the counter is in the least significant bit of the counter word. If the counter transfer order happened to be LSB, it would show you that in the graphic as well. But in this case, it is actually MSB. And it also shows where the SFID is located. In this case, it is in word 1, but say if it was in word 3, you would immediately see it change in the graphic. And it does count from initial value of 1, but you can choose 0, and it'll show you in the graphic as well. But in this case, it doesn't back count 1. Here I've got my frame geometry set for PCM, the PCM stream, which means this should lock up if I've got it right. So let's go ahead and add our other streams. I'm going to add a 1553 stream. And I'll call this one Chapter 7, 1553, 1. There's a reason for that. I'll give it a color here. And I'm going to connect to the first 1553 channel. And then I'm just going to copy this because I have a second one. I'm going to copy the stream. It's going to come up with a conflict because it's mapped to the same channel, but I want to change the name and then map that to the second channel, and the conflict will go away. Back in so you can see it. I'm going to do the same thing with the video channel. On the video channel, there's a lot of settings here, but this is only for controlling our video hardware. If you have video hardware, all these settings are already part of the Chapter 10 stream. So if it's coming out of the sky, there isn't anything you have to do for that. I'll call that video 1. Nice plum color. And I'll pick it. Note that when I'm selecting the source channel, it's only showing me the channel types that are available for that type, in this case, video. And so I can take advantage of that, copy it, and then do the same thing I did with the 1553, which is map that. And then video 2, and then I believe the last one is analog. Analog stream. And feel, like I said, the colors aren't really important. Okay, so now I've got all of the streams set up for this data. And if I did it right and I hit start, you should see locks on all of them. There we go. So I can go to my mission tab, which shows me all of my streams. And I can pick here whichever time I want. In this case, I'm going to use the Chapter 7 time, because that's the time associated with any parameters I might create. I haven't created any parameters. I don't plan on going through that today. But if I did, you can use that time for the parameters, not the time that's on the ground. So the time is accurate for the parameters in that case. If I wanted to create an output file, i.e. a Chapter 10 file from this, so if I have data coming in and I want to create a Chapter 10 file with that data, I can just pick a location to send it, and then I can send all the data over there, or I can use filtered data, which means I can select which channels I'm going to record. Now, the nice thing about this is that I can select all of these, but I can turn off the time and the Chapter 7 stream. So remember, this is the time that's on the ground and when the Chapter 7 stream is acquired. And then just have the time that was coming from the aircraft, or the data rather, time and data that's coming from the aircraft. So then I can set up that recording. I can start processing my data, and then then I'm getting a new Chapter 10 file with only the data that was embedded in the Chapter 7 stream. I've got locks here. While I'm here, we can look at our displays, and we can do some troubleshooting if we want to with the 1553 data or PCM data. And if you have parameters, you can do strip charts and stuff like that. So once you've recorded the data, now I can stop this recording. I'm going to go back to my source. And this time I'm going to pick, instead of my original source, I'm going to pick the file I just created. And you'll notice that this file it doesn't have the time from the ground station or the Chapter 7 stream. It just has the data coming off the aircraft. Now, there's a bunch of conflicts, and the reason for the conflicts is because I have these streams here I already identified. But since I don't need them, I can just delete those two. Those conflicts go away, and now I can play back that data. So for post-mission analysis or stuff like that, I can execute that data. And here I've got just what came off of the aircraft. So that's quick and pretty easy to do. And that also ends my presentation for Chapter 7. So at this point, we can I can answer any questions that people may have, and throw it open to you guys.
Thanks so much, Bill. Yeah, we are open for Q&A. We have plenty of time, so don't be shy. Feel free to send your questions into the Q&A module of the webinar. We'll be happy to field those. And it looks like the first one that I have here for you, Bill, could you elaborate what if the data source is TM over IP?
Sure. TM over IP just means that it's going to, instead of coming through the air as PCM, it probably is coming through the air as PCM, but when it hits the receiver, it's being converted to telemetry over IP. And the only thing that changes here, in this case, is your source. Instead of well, in this case, I'm showing you a file source, but you would actually have an Ethernet source in this case, and then you would put the IP information in here, and then tell it what type of packets it is. So TCP, Chapter 10, UDP, that kind of stuff. And then we also have a specific system called the G3 that is specifically designed for TM over IP. So it actually, that's all it's doing. It's just handling telemetry over Ethernet. I hope that answers your question.
Can you create custom packets?
I'm not sure what you mean by custom packets.
Well, there's some feedback to the person asking the question. Can you elaborate a little bit more on what you mean by custom packets? And looking for questions here. I don't see anything on standby, so everyone feel free to send any questions you have, and we'll hang tight here while you guys come up with whatever's on your mind. A little bit of elaboration for you.
Oh, okay. I see in the message. So yep. the answer to that question is yes. So there is with Omega Next, which is actually a suite of 5 different software packages. But we include in that an API, and one of those is a Ethernet parser API, which allows you to identify your own custom packets in Ethernet. So there's lots of people that are out there doing special things for whatever their mission is. And you can write a packet or a parser to take apart that packet. So just to show you, you can even do an Ethernet stream in here. And this would be kind of an example. I don't have a parser set up for this, but you could create messages as part of that parser and identify where the data is and what it is and what type of data it is, where it's integer, floating point, or anything you want. So the short answer is yes.
Fantastic. Another question coming in here. Which hardware equipment is used with this software?
Well, any of our Parraid products, which are G2, much G2, Parraid, all these are Parraid products. Omega Next, X5000, Series 5000, our data bricks, our receivers and combiners. The only hardware that we directly support that isn't our product is a DBS 140. But most of the time we can, if any product, for example, like all the airborne recorders, output Chapter 10 UDP packets, and we can take those directly. So we can support any airborne recorder that way.
Got it. Okay, and I will just make a reminder comment here while we look for other questions to come in. We have uploaded into the handouts section of the webinar both the slides that Bill went over at the beginning of his demo, as well as some data sheets for the Parraid hardware and these software suites that we've alluded to here. So you'll see those in the handouts, as well as the VMA line card for our telemetry products. So those are all in the handouts. And will also be sent out with the video tomorrow. So if for some reason you have any issues with them today, we will send them out tomorrow with this video as well. So with that, I'm going to look back over here to see. I don't see any more questions coming in here. I'm going to give it another minute or so, Bill. And if we've answered everyone's questions, we'll sign off. But I don't want to cut anybody off too early. So we'll just give them a moment here to fire off any last minute questions.
Yeah, if there are any questions that aren't related to Chapter 7, I'm happy to answer those. They don't have to be specific to Chapter 7.
Absolutely. And, ultimately, we're certainly available to do one-on-one demos and kind of go more in depth with any of the customers out there. So both of our email addresses are on the screen, but you can get a hold of anybody on either team, and we'll be sure to help you out. I don't see any more questions coming in, Bill.
All right. I'll just say one other thing. If anybody out there is already a user of Omega Next and you're having any questions at all regarding the use of the software, feel free to contact me directly and I can help you out.
One more question just came in. You mentioned flight hardware. I assume the software is intended for ground equipment, correct?
That is correct. That is correct in general, yes. However, it is used in flight, and it's starting to be used more in flight. Now, in the past, these are typically fairly large aircraft. They're not jet fighters using this. But there are programs out there which Omega Next is used in flight. However, more recently, we are working on some programs that for smaller aircraft and helicopters, where they're going to have real-time data being processed on tablet PCs with Omega Next on them. So we are in the air in that way.
Got it. Hope that answers that question. And as we wrap up, I think just want to extend our gratitude to all of our customers and to you and the whole team, Bill, for taking the time to do Tech Tuesday. We really want to put these out there as a resource to our customers and their teams. We're in different times these days, so we want to make sure to keep getting information out to the customers. So we'll continue to do our weekly Tech Tuesdays, and we are available for on-site and online meetings. So if there's anything we can do to help your teams get information or go through any specifications of the products we work with, we'd be happy to do that. So I think we'll wrap it up here, as I don't see anything coming in through the chat. We really appreciate everybody taking the time. Stay safe, stay healthy, Thanks so much for your time today, and thanks to you as well, Bill.
Thank you. Thanks for inviting me.